One British gun crew fired continuously for 12 hours straight, 5 million rounds in 7 days without a single jam. The barrel never seized. The mechanism never failed. This wasn't modern technology. This was a design from 1912. The Vickers machine gun didn't fire the fastest. It wasn't the lightest. It certainly wasn't the newest. Yet for 3 decades, it remained the most reliable, sustained fire weapon on any battlefield. And German infantry learned to dread the distinctive sound of its water-cooled mechanism, settling into a rhythm that simply wouldn't stop. Modern machine guns fire faster, weigh less, and use advanced materials. Yet in sustained fire trials, none have matched the Vickers' legendary 1963 test at Strensel Barracks. The gun that Victorian engineers designed using steam engine principles proved more reliable than weapons developed with computer-aided design. How did Edwardian-era engineering achieve what modern militaries still study? The answer lies not in rate of fire, but in a cooling system so elegant that crews could maintain fire for hours, whilst enemy guns seized after minutes. The Vickers emerged from a simple observation. Machine guns failed because they overheated. The solution seemed obvious: cool the barrel. But how? Earlier attempts used air cooling, which worked until sustained fire raised barrel temperatures beyond 600 degrees Celsius. Metal warped, mechanisms jammed. Crews watched helplessly as their weapons became useless exactly when needed most. Vickers took inspiration from an unlikely source: the steam engine. If water could cool industrial machinery running for days, why not a gun barrel? The result was a 7-pint water jacket surrounding the barrel completely. But this wasn't simply a tank of water. The engineering was far more sophisticated. As the gun fired, water absorbed barrel heat and converted to steam. That steam needed somewhere to go. Vickers engineers designed a condenser can system, a tube leading to a separate container where steam cooled back to water. This created a closed-loop system. Water never depleted if crews maintained the condenser. The barrel temperature stabilized at approximately 100 degrees Celsius, well below the failure point of the mechanism's moving parts. But water cooling created a new problem: weight. A loaded Vickers weighed 23 kilograms without the tripod. Add the tripod, ammunition, water, and spare parts, and a gun team carried over 50 kilograms. Critics called it obsolete, too heavy for modern mobile warfare. German military observers in the 1920 seconds predicted rapid-fire, air-cooled weapons would replace it entirely. They were wrong. The weight wasn't a flaw, it was a feature. That mass provided stability. Air-cooled guns jumped and vibrated during sustained fire, sending rounds wide of their mark. The Vickers sat rock-steady, delivering accurate fire at ranges exceeding 2,000 meters. British doctrine understood something that faster, lighter guns missed. Warfare isn't won by firing the most rounds per minute. It's won by firing effectively for the longest duration. Comparison diagram: Vickers stable firing versus MG42 barrel climb. But effectiveness required more than just engineering. It demanded a complete training doctrine that turned 2-man crews into experts in sustained fire. What separated a Vickers crew from other machine gunners? A Vickers wasn't operated. It was conducted like an orchestra. The number 1 gunner controlled firing, traverse, and target selection, but the number 2 was equally critical, managing ammunition feed, water levels, and barrel changes. Both men trained for months to work in perfect synchronization. British training manuals specified procedures for every scenario: ammunition belts, fed from the left in a specific arc to prevent binding. Water levels required checking every 100 rounds. The condenser can needed emptying at precise intervals. Most importantly, crews learned the 1 inch short, 1 inch over method. This technique turned the Vickers into an indirect fire weapon. Crews didn't aim directly at targets. They fired in arcs, dropping rounds onto enemy positions hidden behind terrain. A gun positioned on high ground could suppress areas its crew couldn't even see. Critics argued this seemed wasteful, firing blindly in hopes of hitting something, but the mathematics proved devastating. A Vickers firing at 450 rounds per minute created a beaten zone 3 meters wide and 30 meters deep. Enemy soldiers couldn't determine where rounds landed most densely, only that moving meant death. German infantry manuals, from 1917 onwards, carried specific warnings about British indirect machine gun fire. Units were instructed to avoid any position that might fall within Vickers range, even if the guns weren't visible. But training alone couldn't explain the Vickers battlefield performance. The real test came in combat. The Somme offensive saw machine guns used in ways never previously attempted. At High Wood, on 24 August 1916, a single Vickers section demonstrated what sustained fire truly meant. The 100th Machine Gun Company positioned 10 Vickers guns on high ground, overlooking German positions. As British infantry prepared to attack, the guns opened up not for minutes, but hours. Crew member Private William Cole later described the experience. The barrels glowed. Steam poured from the condenser cans. We changed barrels every hour, but the guns never stopped. The number 2 would tap my shoulder, I'd lift slightly, he'd swap the barrel in seconds, and we'd continue. The 10 guns fired continuously for 12 hours. Total rounds expended, approximately 1 million. Not a single gun jammed. Not one mechanism failed. German defenders reported the fire as unendurable. Soldiers couldn't leave trenches. Reinforcements couldn't advance. Supplies couldn't move forward. The sustained fire created a barrier as effective as physical obstacles. Modern analysis suggests this was inefficient, 1 million rounds for limited tactical gain. But efficiency misses the point. The Vickers achieved something no other weapon could: complete area denial for half a day without pause. The High Wood demonstration changed British doctrine, but it also revealed the gun's most remarkable capability, one that wouldn't be fully understood until decades later. What actually happened inside the Vickers during those 12-hour marathons? The answer required understanding how the mechanism prevented failures that plagued other designs. The Vickers used a toggle lock system derived from the Maxim gun. As each round fired, recoil drove the barrel and bolt backwards. A toggle joint 2 metal arms, connected at a pivot, collapsed downward, unlocking the breech. The spent cartridge ejected. A spring pulled the bolt forward. The toggle joint straightened, locking everything solid. The firing pin struck the next round. This cycle repeated 450 times per minute. The brilliance lay in the timing. The mechanism opened for precisely the duration needed to cool slightly before the next round chambered. The water jacket maintained consistent barrel temperature, preventing the thermal expansion that caused other guns to jam. Technical diagram: toggle lock mechanism, animation. But one component remained vulnerable: the barrel itself. Even with water cooling, barrels wore down, rifling degraded, accuracy decreased. British armourers determined a barrel's effective life at approximately 10,000 rounds before requiring replacement. This created a problem. How could crews maintain fire if barrels wore out? The solution was elegant: hot barrel changes. A Vickers crew could swap barrels in under 30 seconds without ceasing fire. The process required perfect coordination. As the number 1 continued firing, the number 2 prepared a fresh barrel, cooling it slightly with water from the condenser can. At the designated moment, the number 1 stopped firing mid-belt. The number 2 loosened the barrel casing lock, a simple but precisely engineered fitting. The hot barrel slid out backward. The fresh barrel slid in. The lock secured. Firing resumed. The entire operation took less time than reading this paragraph. Sergeant Arthur Green, 51st Machine Gun Battalion, recalled, "We practiced barrel changes blindfolded, in smoke, with gas masks on. It became automatic. The gun stayed in action because we could swap barrels faster than the mechanism could overheat." This capability separated the Vickers from every contemporary weapon. The MG8 required similar barrel changes, but took minutes and exposed crews during the swap. The Hotchkiss used fixed barrels that eventually failed. The Lewis gun's barrel change meant removing the entire mechanism. Only the Vickers allowed truly continuous fire. But mechanical reliability meant nothing if ammunition ran out. The Vickers demanded feeding. A Vickers firing at standard rate consumed 450 rounds per minute, 27,000 rounds per hour, over 300,000 rounds for a 12-hour period. Keeping that rate supplied required logistics on a scale rarely appreciated. British machine gun battalions developed specific supply systems. Ammunition arrived in belts of 250 rounds. Each wooden case held 4 belts, 1,000 rounds total. For a sustained fire mission, crews positioned dozens of cases within arm's reach. Runners continuously brought forward fresh ammunition. In defensive positions, dedicated supply chains functioned like factory production lines. The number 2's skill became critical here. Belts needed joining without interruption. The technique involved overlapping the last few rounds of one belt with the first of the next, creating a continuous feed. A skilled number 2 could maintain belt continuity indefinitely. The gun never paused for ammunition changes. It simply kept firing as long as rounds arrived. Critics pointed out this created enormous logistical strain. True, but British doctrine accepted this trade-off. A single Vickers delivering sustained fire proved more valuable than multiple rifles firing intermittently. The question German infantry asked wasn't how many rounds, but when does it stop? German military analysis of British machine gun doctrine began as early as 1915. By 1917, Wehrmacht field manuals contained specific sections addressing Vickers positions. The advice was stark: avoid them. Captured German documents reveal the reasoning. Standard infantry tactics assumed machine guns fired in short bursts, creating gaps for advance. Troops learned to move during pauses, counting on the enemy reloading or allowing barrels to cool. The Vickers didn't pause. German after-action reports noted continuous fire that made movement impossible. Units reported casualties mounting from sustained fire that gave no opportunity to advance or retreat. One Wehrmacht training document from 1943 stated, British Vickers positions must be neutralized by artillery or flanked completely. Direct assault against continuous fire results in unacceptable losses. This wasn't fear, it was tactical pragmatism. German commanders recognized that sustained fire created kill zones no amount of courage could cross. The MG42, Germany's rapid-fire weapon, fired faster 1,200 rounds per minute. Shouldn't that have been more effective? The MG42 became legendary for its incredible fire rate. The sound so fast individual shots blurred into a continuous buzz terrified Allied soldiers. But tactical analysis reveals a paradox. The MG42's speed was also its weakness. At 1,200 rounds per minute, the MG42 exhausted ammunition rapidly. Barrel changes occurred every few hundred rounds. Crews couldn't maintain continuous fire for more than brief periods. The Vickers, firing at roughly 1/3 the rate, delivered fire far longer. Over a 12-hour period, a Vickers achieved greater total volume simply by never stopping. MG42 in 12 hours, accounting for barrel changes, ammunition resupply, cooling. Approximately 60,000 to 80,000 rounds. Vickers in 12 hours, continuous fire with hot barrel changes. Approximately 270,000 to 300,000 rounds. The slower gun delivered 3 times the total fire. British infantry officer, Captain James Morrison, 7th Division. We heard the German Spandaus buzz terrifying noise, but it stopped regularly. Our Vickers kept up that steady hammer. Slower, yes, but relentless. That's what held lines. The ultimate proof came not in combat, but in a test that would become legendary. In August 1963, British Army weapons inspectors decided to test Vickers' reliability to destruction. They selected a gun manufactured in 191746 years old, positioned it at Strensel Barracks firing range, loaded ammunition, and began firing. The goal? Fire until something broke. Over 7 days, in 12-hour shifts, crews maintained continuous fire. Barrels changed hourly. Water refilled constantly. Ammunition belts fed endlessly. 5 million rounds. The gun never jammed. The mechanism never failed. Only the barrels wore out exactly as designed and were changed as per standard procedure. This wasn't combat conditions. It was more demanding. No pauses for tactical necessity. No breaks for safety. Just continuous mechanical operation to test absolute limits. Modern military analysts, studying the test, noted that no current machine gun could replicate the performance. Advanced materials and design hadn't surpassed 1,912 engineering for sustained fire reliability. Some argue modern guns don't need such endurance. Doctrine has changed. Fair point. But the Strensel test proved what British crews claimed for decades. The Vickers could fire longer than any crew could feed it. So why did militaries eventually retire this marvel of engineering? The Vickers remained in British service until 1985, 6 years of frontline duty. No weapon before or since has matched that service length whilst remaining tactically relevant. Its retirement came not from failure, but doctrine change. Modern infantry warfare emphasized mobility, rapid deployment, lightweight. The Vickers' 50-kilogram battle weight became a liability when troops needed to move quickly across varied terrain. The L7 GPMG, general-purpose machine gun, replaced it lighter, more portable, adequate for most situations. But adequate wasn't superior. Former Vickers gunners noted the L7 couldn't match sustained fire capabilities. It overheated faster, required more frequent barrel changes, delivered less total fire over extended periods. Sergeant Major Robert Davies, who transitioned from Vickers to GPMG, the L7 was fine for most jobs. But when you needed absolute suppression for hours, nothing beat the Vickers. We gave up reliability for convenience. Today, militaries have rediscovered sustained fire's value. Modern weapon systems increasingly emphasize thermal management and barrel life. Engineers study the Vickers water cooling system when designing next-generation weapons. What lessons does this Victorian-era design hold for modern warfare? The Vickers wasn't the fastest machine gun. It wasn't the lightest. It wasn't the most advanced. It was the most reliable. That reliability came from engineering philosophy. Solve the fundamental problem completely, rather than optimizing secondary characteristics. Other designs prioritized rate of fire, weight reduction, or manufacturing cost. The Vickers prioritized sustained operation. Every engineering decision served that goal. The water cooling system seemed heavy until crews needed to fire for hours. The toggle lock mechanism seemed complex until it ran for millions of rounds without failure. The two-man crew seemed inefficient until perfect coordination enabled barrel changes mid-fire. Perhaps Major General Julian Thompson said it best. The Vickers was Victorian engineering at its finest. Simple principles executed perfectly. Modern designers chase innovation. Sometimes we should chase reliability instead. 5 million rounds in 7 days. 12 hours of continuous fire. 56 years of service. The Vickers machine gun proved that sustained fire matters more than rapid fire. That reliability beats innovation. That Victorian engineers understood truths modern militaries are rediscovering. Water-cooled, belt-fed, unstoppable.